What is going on, guys? My name is Bucky Roberts and welcome to your very first tutorial in chemistry. Now, I know there's probably a cute little girl in college out there thinking, "Oh, Bucky, your voice is so sexy. There might be some chemistry between us." Well, cute college girl, I'm sure you're right. However, that's not the kind of chemistry we're talking about today. In these tutorials, we're going to be talking about this kind of chemistry: the study of the composition and properties of matter and the changes it undergoes. You're like, what the heck is matter? Never even heard of that before. Well, here's my definition. Chemistry is basically the study of stuff. Now, what does that mean in everyday terms? It's basically figuring out whenever we take something and break it apart, what is it made of? What stuff makes up that stuff? And how can we combine two things to make more interesting things? So we pretty much take stuff, break it apart, see what's inside it, and then once we find the ingredients, we use those ingredients to make other stuff. So you're like, all right, it sounds pretty interesting, but I'm not entirely sold yet. Well, here's a couple cool things that you can do with chemistry. You can make medicine. For example, say that there is a disease that is going around like the new Black Plague or something, and no one can find a cure for it. What they would need to do is a bunch of chemists would need to get together and, find this new awesome chemical and develop this new medicine that can fight that disease. So, if you're into that, you can do that. Another thing is developing new types of fuels because this is what they're working on right now. The fuel and gas that we put in our car is like dirty and it releases a bunch of harmful byproducts into the environment. They're trying to develop a new type of fuel now that is clean, doesn't hurt the environment at all, and it's also more efficient than gasoline or oil, whatever, diesel, whatever the heck you run your vehicle on. So, hey, if you want to go ahead and do that, you can go ahead and do that. But what I am interested is in this one: solving the mysteries of the universe. That's why I studied chemistry, because I had a bunch of questions about the universe, and in these tutorials, we're going to answer them all. If you have any questions about the universe, where we came from, what's going to happen, all this crap, oh yeah, that's where we're going to be getting into some deep crap. So get ready. So, on the subject of the universe, there are two main things in the universe. And I say two main things. There are only two things in the universe: there's matter and there's energy. Now, the definition of matter is a substance or material. And you're like, okay, and matter, energy, what the heck does this mean? What matter means in everyday's term, and I'm pretty much going to take what chemistry books tell you and explain it to you in terms that you can understand. Matter is all the stuff that you can touch and feel. It's the stuff you can put your hands on, and even some of the stuff you can't. For example, your book is matter, your hat is matter, you are matter. Touch your computer, it's made up of matter. It's any material that you can touch, and it's even stuff like oxygen and carbon dioxide. All that is matter too. So it's basically anything that you would think of as a thing. Now, the only exception to that is this little bugger right here, and this is energy. Now, we separate matter and energy because, like, you can study matter in a way that you can look at it and it has properties, but energy is like a whole different beast. So we're getting into that later on. And that's why I define it as what little kids gets when they drink soda. And that should be get, but what little kids gets, that's like something a little kid would say. So I'm not fixing that typo. F that. So let me go ahead now and talk to you about the three different kinds of matter. And if we want to get technical, then there are actually more than three different kinds of matter. There's actually a fourth one called plasma, but we'll worry about that later. So matter comes in three main types. The first one is a solid. Now, solids have a definite shape and a definite volume. And what I mean by this is, if you have something like a piece of ice, you can go ahead and you can see the shape of it and it doesn't change unless it melts, of course, and that's something different. And it also has a volume, a set volume, and volume just means how much space does it take up. Now, the particles in solid, if you look at them under a microscope, they're packed really tight together and jammed together, and that's why when you pick up a solid, it doesn't flow, it doesn't move around. It's like it stays still. It's not like a gas or a liquid where it can move around. All those particles are jam-packed and stuck together. Now, a liquid, on the other hand, it's defined as, well, this isn't definition, but here's some properties: no definite shape, but a definite volume. For instance, an example of a liquid would be water. Now, what do I mean by no definite shape but definite volume? If you had a cup of water, it would take up a cup the same area no matter what shape it was in. For example, if it was in a tall, skinny glass or a short, fat glass, like a plate or something, if you dumped it on the floor, it would be a different shape, but it would take up the same area in the universe. It would take up one cup no matter what. So, anyways, the particles in liquids are they aren't jam-packed as tightly as a solid. They're like kind of clumped together, still kind of connected in a way, but they have room to flow. So, it's solids are jam-packed and liquids are kind of clumped together, but they kind of got some wiggle room. Now, gas, on the other hand, the particles in gas, they're just all over the place. They're like a bunch of kindergartner kids left, wild, roaming around the school. They just kind of all spread out, do their own thing. Gas has no definite shape or no definite volume. An example of a gas would be steam. Whenever you boil water, it converts to a gas, and that gas is called steam. So again, like I said, the particles in gases are all buzzing around crazy. In the air right now, there's a bunch of oxygen and some other gases, and it doesn't have a shape, and you can't like measure the volume of it. So maybe it'll be easier if I show you this picture right here. Now this is a picture of a solid is in this beaker. Liquid is in this one. Let's call this looks like, what's blue? A blueberry pie? No, no. This is like a rock, I guess. And this is some Kool-Aid. And this is some, let's say, oxygen in this one. So in this rock, if we look at all the little particles, and if you can't see this, change your video resolution on YouTube to 720 in full screen, and you should be good. If you look at all these little particles, they're all jam-packed together and they can't move much. So that's why this solid, it doesn't flow like water or gas. Now water, if we look at these particles, they're still kind of packed together, but they're kind of connected. It's like kind of, they have room to wiggle. So that's why liquid can change shape, because the particles can kind of slide and slip around. Now this gas, however, it has no shape and no volume. It's going to take the shape of whatever container you put it into. It's just going to spread out wild. So these particles are just zipping around the air like, I'm going to do my own thing, do whatever the heck I want. So they're all like kind of going crazy. So that's how particles, if you look at these things under a microscope, this is what you would see. In solids, they're all jam-packed together. In liquids, they're like kind of cool, easy flowing, kind of clumped together, but kind of not. And gas is just like wild, crazy kids. Do you remember that show, Wild and Crazy Kids? Oh, I want to go watch it right now. So on that note, I'm going to pause the video and I'm going to go on YouTube and watch some Wild and Crazy Kids. But anyways, thank you guys for watching. Don't forget to subscribe, and I'll see you next time.